Let S be the set of positive integer n with the property that the last four digits of n are 2020. When the last four digits are removed, the result is a divisor of n. For example, 42020. 42020 is in S because 4 is a divisor of 42020. Find the sum of all digits of all numbers in S. For example, the number 42020 contribute 4 plus 2 plus 0 plus 2 plus 0, which is equal to 8 to this total. Therefore, I think we use this example as a discussion first. That means this is actually 42020. This is being removed, right? And then this number 4, and this number is actually n, right? This number is actually n. And what does it say? It says that this number left behind, 4, is in fact a divisor of n. Or is fact as a divisor of n. Therefore, I think in general, we look at the general n, and the general n can be expressed as, can you say that this is actually the 10,000 position. Therefore, it's actually 10 to the power of 4 multiplied by m. All right. And then plus what? Plus 2020. And according to this question, isn't that this m, after removing the last two, right? The last four digit, after removing this last four digit, this m is a divisor of n. That means in this case, isn't that n can be expressed as k times m. Right? I think if you use this example, then I think you can generalize it to this general case, right? Therefore, now we can see that 2020 is actually what? Is actually k minus 10 to the power of 4 and then multiplied by m. Right? And then from here, you can see that n must divide 2020, or n must divide 2020. And now we look at the prime factorization of 2020. It is actually 2 to the power of 2 multiplied by 5 multiplied by 101. All right. And then what? In this case, how many factors? Number of factors will be just equal to what? The number of factors will be just equal to 2 plus 1. 2 plus 1, and then this is 1. Therefore, 1 plus 1. And then this is 1. Therefore, this is 1 plus 1. In total, that will be 3 times 2 times 2. Therefore, there are 12 factors. That means there are actually 12 cases for us to study. 12 cases for us to study. Okay. Okay, what are the 12 cases? Basically, it is actually 1, 2, 4, and then 5 times 10. Therefore, in this case, 5 cases already, and then 20, 6 cases, 6 cases. And then after that, move on to 101, 7, 202, 7, 8. Then after that, 204, 9. And then 505. 505, 404, sorry, 404, and then 1010, and then 2020. Therefore, this is 10, 11, 12. 12 cases. All right. Okay. Therefore, let's look at this. Let's look at this. That means we are looking at your m can be 1, right? Then your big N will be just equal to 10 to the power of 4 times 1 plus 2020. All right. And then m equal to 2. Your n can be 2. Then your big N will be just equal to 10 to the power of 4 multiplied by 2 plus 2020. Then I think the next one we consider m equal to 4. Then your n will be just 10 to the power of 4 times 4 plus 2020. And then the whole thing go all the way to m equal to 2020. And then your n is actually 10 to the power of 4 times 2020, and then plus 2020. All right. Therefore, the sum of all these digits, the sum of all these digits, can you see that actually is equal to what? Okay, you can think of it, sum of all the digits, of all the numbers in S. In S, S is actually what? Okay, S is the positive integer with the property that the last four digits of n are 2020, and when the last four digits are removed, the result is a divisor of n. That means in this case, we are looking at the collection of all such number big N, or big N. Okay, then can you see that this part here, this part here, if you look at it carefully, okay, this is actually 1, 1, 2, 4, and then the next one is 5, right? The next one is 5, okay. Then the next one is actually 10. But 10 is actually 1040 multiplied by 10. It's only one that is counted, right? And then followed by 20. Therefore 1040 times 20. Therefore only this one counted in terms of digit sum. Then after that you look at 101. That means it's 10 to the power 4 times 101. Actually you counted these two. Right, counted these two. And then okay, then you can count 202. 202. Therefore I think the way you count is actually what? It is actually, can we see that we look at this sum here, we look at the digit sum of this. It is actually, can you see that it is 1 plus 2 plus 4, and then as I explained, when it comes to 5, okay, this would be 5. When it comes to 10, actually it counted 1 only. When it comes to 2, it's counted 2 only. Alright, and then after that 101 is actually 2, right? 101 you counted is actually 2, right? And then after that, can you see that you look at 202, 202. Okay, 202 is actually 4, right? 202, 10 to the power 4, 202. Therefore 2 plus 2 is actually 4. Therefore this is 4. And then after that you look at 404. Therefore this would be 8. And then you look at 5 plus 5. That will give you 10. And then after that you look at 1010. That means it's 10 to the power 4 times 1010. That will count it as 1 plus 1. Therefore this is 2. And finally 2020. Therefore this part is 4. Therefore can you see that I count the digit of the front part here, right? And then this part here, it always contribute 2 and 2 is actually 4, right? And how many numbers are there? Total 12 numbers. Therefore it is actually 12 times 4. And then the sum of all these turn out to be 93. That's it. Therefore I think it's a interesting question in a sense. All right.